Section 4.7, number 31. We have a sphere and inscribed inside it is a cylinder. We would like to maximize the volume of the cylinder. And so with this type of problem, we need the volume of the cylinder is what's important. So I think you are required to memorize it. Its volume is equal to pi x squared, we'll say y. The reason for that is because, well, it's pi r squared times h. But we will associate the r with the radius of the circle. So we don't want to confuse variables here. And obviously the radius of the circle is not equal to the radius of the cylinder. So the radius of the circle, we'll say, is r. And x squared is the radius of the cylinder. X. And the height will be y. And so remember that any point from the center of the circle to the outside edge is the radius, right? So from here until the outside edge is r. Well, then we can pull out this right triangle. We know that the hypotenuse, as we can see, will be r, the radius of the sphere. The height will be y divided by 2. It will be the height of the cylinder divided by 2 because it's right here, y, but we're splitting in half, so y divided by 2. And then our adjacent side will be just the radius of the cylinder. So we can pull out this right triangle. We'll have x, we'll have y divided by 2, and our hypotenuse will be r, the radius of the sphere. And so we can use Pythagorean theorem here and solve for a variable which we will plug back into here and then take the derivative. And so let's solve for x. So x squared is equal to r squared. Yeah, so the reason I'm solving for x is because we're going to take the square root of everything, and if I plug it back into here, square root will be demolished. And so we don't have to deal with a chain rule and product rule, just a product rule. And so let's solve for x. We'll have x squared is equal to r squared minus y squared minus divided by 4. So x is equal to the square root of this entire thing. And now we want to substitute it back into our volume equation since we want to maximize the radius of the cylinder. So let's not write v prime. There's many variables here, so we want to distinguish which variable we're taking the derivative with respect to. So let's write dv. Let's write dv by dx instead of v prime. And so let's substitute everything back in. The volume is equal to pi r squared minus y squared divided by 4. The square root got cancelled with the squared times y. And always before you take the derivative, see if you can simplify. Let's multiply. Let's FOIL this y and keep the pi out at front. It's a constant, so let's not worry about it. And so expanding the y, r squared y minus y cubed divided by 4. Sweet. And now we can take the derivative. Doesn't look like we can simplify it any further. So then we can write dv by dx by dx. No, I'm sorry. By dy. That's right. By dy. dv by dy. The derivative with respect to y. So yeah, we would like to maximize also the height of the cylinder. And so constant stays out front. R squared times y will just be r squared minus y cubed divided by 4 will be 3y squared divided by 4. And so we would like to set this equal to 0 and solve for y. So we'll say, oh, actually, before we do that, let's take the second derivative, since we want to verify our answer is maximum or minimum. So at this point, take the second derivative. V double prime, or d2 of v, is equal to pi This will be 0, will be negative 6y divided by 4. And so we see here that since we want to maximize the volume of the cylinder, we need the second derivative to be a negative since it will be concave down at that point. So in mind, we need the first derivative to be a positive, since when we plug it in here, it will be a negative. Awesome. So go back into here and solve for y. Let's equal to 0. Solve for y. The constant's not really important, or we can say we want to divide everything by pi. So we'll have r squared is equal to 3y squared divided by 4, and solve for y. Multiply first the constant, so we'll have 4r squared divided by 3 is equal to y squared. Take the square root of everything, it's equal to y, and then simplify it. Square root of the numerator will be 2r, denominator will be root 3. And now that we've solved for y, we can actually plug it back into any of these equations, whichever one will be easier to simplify the y, and then you're done. R squared times 2r divided by root 3 minus y cubed. So this whole thing will be cubed, so it will be 8r cubed divided by 3 root 3. And then, okay, don't do too many steps at once. 8r cubed divided by 3 root 3 times 1 over 4. Let me just mention that at this point we took the positive root. The negative root would give us a concave up since it would be positive at the second derivative, so we're just taking a positive root. And so if we simplify this, multiply this r squared by this 2r divided by root 3, multiply the 1 over 4 times this, you will be left with 2r cubed divided by root 3 minus 2r cubed divided by 3 root 3. Multiply this by 3 to take a common denominator, you'll be left with